All right, let's get started. So today we're proposing a project of computational heritage science, which is an exploration of artificial intelligence integrating with cultural heritage as an ecosystem. So the idea really originates from medical informatics. So back in 2004, President Bush enforced the idea about having a unified electronic health record system across the country for hospitals. And currently, thanks to the developments in large language models and decision support systems, those large quantity of data can be excavated in a way that can help future decision-making processes. So using data-driven techniques, we can explore those large body of data from the EHR or electronic health record system, and then draw inferences when we're facing new cases in medicine. So when you think about it, for medicine, we're trying to save a patient's life or try to make their life better by improving their health. So in conservation, we are facing the same thing because the key idea about conservation is trying to improve the quality of life or um, the expectancy of those cultural artifacts. So pretty much we're treating the same thing, right? So in medicine, it's patients, and in conservation, it's artifacts. So those two fields kind of have the same ultimate goal. So we can really transfer what we already have in medicine into the current conservation science. So here's our envisioning about the past, present, and future for computation heritage science. So in the past, we may have some vague idea about where to excavate. And then after the excavation, we have these artifacts. We'll just send those artifacts into institutions for study or for to museums that can just exhibit the artifacts for public education. Um, and now we are gaining more and more knowledge thanks to the developments of more diagnosis techniques. We can run different tests on the objects. We can have different parameters to evaluate the conditions that the objects are in. Yeah, so we are gaining more and more knowledge. However, those are only for our object-to-object basis. That being said, the domain knowledge for experts are only for that person, for that experts, and then the case knowledge is only limited to that artifact. However, we envision a future where all those knowledge from the expert domain knowledge, from the single artifact data, including the devices and techniques. So those dots can be connected somehow, and then using this web of knowledge, we can draw inferences. So say like we can refer to the conservation procedure of a object that has a similar condition as the one we are facing right now, and then using a similar approach to conserve the object that we have. So we believe that this approach will efficiently boost the process of conservation and really assist or boosting the life expectancy of those artifacts, saving a lot of trouble to find new ways to either like through literature review or finding like completely new approach to handle this object, because there are cases that we have handled before that might be similar to the one that we're facing right now. So having a web of knowledge is I guess like a source where we can draw from in order to make more decisions. So before we get into a detailed breakdown about the project developments, let me just break down some terminologies that we'll be using throughout the presentation. So the first word is electronic health record or electronic records. So this is meaning to have a structured online database that stores the record for subjects or entities. So for example, when we're talking about the electronic health records, those are storing profiles for patients, like they're for each hospital visits, their lab test results, if there's any medical image results, sort of CT, X-rays, or MRI scans. Also, there might be doctor notes. So over the time, as more and more data accumulates, the medical history of one person can be represented through the electronic record. So the same thing can be applied for the conservation field. The second word is text mining. So text mining is an approach where we are trying to find hidden patterns within a large body of text through a process that we call natural language processing. So natural language processing handles human languages as texts. So that way we can find any trends in a given text. We can see if these two articles are having the same emotions. We can classify different articles based on how they word, etc. So this is how text mining works. So the third word is multimodality. So multimodality basically means the ways that we can represent data can be, there are multiple ways of representing data. For example, we can either use textual data to represent. We can use images, we can use videos and audios. For example, right now, you can see me through the webcam. This is a video. You can hear me through audio. And the slide as a whole, this is an image. And then the text that I have inside is textual data. So this is really a multimodality world. So in order to capture all the nuances of a certain subject, we need to have like multiple ways of representing it. So this is what we call multimodality. And fourthly, we have large language models, which can be abbreviated as LLMs. So large language models are deep learning algorithms that are recently becoming more and more prevalent, that can recognize, summarize, translate, predict, and generate content using very large data sets. So previously, large language models, like as the name suggests, is mainly focusing on languages. So you can generate human-like languages such as ChatGPT. You can communicate with it. It's just like communicating through with another person on the other hand of the computer. However, as the model evolves over time, large language models can handle multimodal data. So currently there are multiple research going on showing that large language models are capable of handling both textual as well as images as well as video data. So you can simply put in a short description about how you want the image to be, and then the AI will just generate a similar image according to your description. So this is how large language models have like a huge room of opportunities for integrating into different subject fields. And then second to the last is graph neural networks. So graph neural networks means we are representing entities as graphs, and then we can show their relationships. And using these type of neural networks, we can perform inferences on data described as the graphs. So it is a really helpful type of architecture in the field of recommendation systems. So it might come in handy for the project. And then last but not least, we are aiming for a decision support system. So in simple terms, decision support system is a program that kind of improve the overall decision-making process. It is widely applied in different fields, in finance, in management. So decision support is basically saying that this computer program can help us derive plausible and effective decisions using either previous data or any inference drawn from like a graph neural network, etc. But yeah, so that's so much about the terminologies that we'll be using in later on in the presentation. All right, so in essence, the computational heritage science concept can be captured through this Venn diagram. So pretty much in order for us to achieve the ultimate goal of having a self-contained decision support system, we need to have two things. So one being the multimodal large language models, which can handle different modalities of data. So preferably we should have text and images as the data. So that way we can construct we can use images to draw inferences as well as texts. Also, we should have a electronic record for the artifacts. So having these two combined will really give rise to a decision support system that we are aiming for. So let's just break down the project developments. So it can be broken down into 4 phases. Phase 1 is basically using text mining approach to mine currently available heritage science literatures. So the goal of this phase is to see the trends evolving over time in the field of heritage science, as well as identifying any entities that we need when we are creating the database. So at the same time, we'll be extracting textual data because we already have all these large bodies of publications available to view. It's just how we can organize those large quantity of data in a structured format and easy for people to access it. At the same time, besides text, there's also images embedded in the publication, so we might just also scrape those informations and as needed. And then using those informations, we'll be also we will be moving on into phase 2, which is a database creation process. So besides the text and images data we collected from currently available heritage science literatures, we'll also be constructing like a platform where conservators and conservation scientists, when they're writing a condition report for a artifacts being conserved, they can use this platform to do the report, and then the report will just stored in a structured format. So that way, all the things are tidied and organized. So after we have a pretty comprehensive database as a support, we can move on to phase 3, which is actually building the decision support system. So we are considering two models to run parallelly. So the first one is using a multimodal large language models. So this will be a pretty potent model to use because it can handle different modalities of data, which fits our purpose pretty perfectly. And then we are also considering a graph neural network, which can help us to derive the logic of thoughts that leads to the decision that we ultimately have. So in terms of like how to conserve an object, so it can give references to like maybe like a year earlier, somebody else from another place did a similar thing to the object, and we can reference that to see if the approach is really valid or not. And moving on to the final phase, phase 4. So this will be actually like actuating the decision support system in real life situations. We'll be going into an expert evaluation phase, a citizen science platform where the citizens are encouraged to share what they have, like an antique they have at home, through the platform. So that way, the database that we have can be bolstered. And it can also, we're also aiming to have educational tools, which we can educate future generations of conservation scientists and conservators. So just to summarize, the key idea of our project is basically mapping the computational methods we have in medical informatics into the field of heritage science and conservation science. So the potential deliverables of the project includes, first of all, publications on both longitudinal as well as cross-sectional topic and trend analysis of the field of heritage science. So after text mining, we should be able to have a rough idea about how the field evolved over time. And then furthermore, we will have a multimodal heritage science database, which involves different modalities of data for the field of conservation and heritage. We are also aiming for a decision support system, which has 2 parallel models. One is the multimodal large language models, for decision support, and the other one is for graph neural networks for recommendations, and then drawing inferences from previous works. So for some extension applications, we're considering having a citizen heritage science engagement platform where we are encouraging citizens to also participate in the process of conserving historical artifacts. So they can either share their ideas or share their household items that does hold some historical values. Also, it is possible to do a provenance identification if we're considering collaborating with other archaeology or historical studies. There's also possibility for educational tools to be made based on the knowledge graph or like the web of knowledge. So using these educational tools, a new generation of conservation scientists can be trained to see how to better prepare or protect the cultural artifacts, the gifts from the past. And that's all for the presentation.